All right. What's up, ladies and gentlemen, boys and girls, young scientists in training? Let's get started today. So I want you to imagine today's like the first lesson in my class. We're going to be doing IB-DP chemistry. So I'm actually just going to use like the same materials and slides that I use for my regular class. So some things may not make perfect sense for you two, but we'll just go through it as it is. So my name is Alex. I am an IB-DP chemistry instructor, and we're going to start right from the beginning today. So usually I ask my students, like, what do you think we study in chemistry? What do you think you're going to learn this year? And we can't do that here, obviously, but usually the answers I get are things like explosions, fire, batteries, electricity, what else? Maybe drugs and medicine, fuel. And usually I get a pretty good list, but it's really focused on those exciting things that everybody knows. And I try to let people know that we're in high school and maybe entering university soon. And the thing that I would like them to understand is that, yes, we will study all or most of those things, but it's not just the qualitative observations. So it's not just seeing awesome videos of these things and saying what happened, describing with words what happened, but mathematics is the language of our universe in some sense, and we need to try to predict exactly what's going to happen. And if we want something to happen, we have to predict exactly how much material we will need and what kind of setup we will need. So that's sort of the big part of this course, is after we spend some time learning about the reasons of what happens and thinking about the qualitative side, we'll look at the quantitative side very often and get into the mathematics of it. So maybe this is not really necessary, but my background, I often try to tell students like why they should kind of take what I'm saying seriously and trust me as an instructor. I'm not really an absolute expert on chemistry. I have a bachelor's degree and some master's and work experience. But just to go through this, I have a Bachelor of Science in Chemistry. My focus was really on organic chemistry and organometallics. I've also been a university teaching assistant, or TA. Some of you guys might know these are people who work at university, usually graduate students. I was a graduate student, and they do sort of the boring work that professors need to do but kind of don't want to do that their students can do. So what do I mean by that? I mean leading like tutorials. A lot of classes you have will have a tutorial section as well where you can go and learn with a TA and groups of other students. They will also, TAs will also mark exams and homework and, just kind of work that the professor doesn't want to do, but the graduate students have enough knowledge to complete. Also, running the laboratories. That was a big part of my job as a TA, is I would have a group of, 6 to 12 students doing practical experiments in the laboratory. And it was up to me to supervise them for safety, make sure they have all the materials they need, make sure they're on track to get the results they need, and then mark their reports. So that was a really good experience. Environmental laboratory work experience. So after I left graduate school, I didn't graduate, just let's make that clear. Maybe that's another story for another video if you guys are interested, but I decided sort of that academia side of research wasn't really for me, so I wanted to try the industry side. I went to an analytical environmental laboratory. So there I did a lot of tests on like water, oil, and soil quality, among other things. So just some specific tests that I ran was like biochemical oxygen demand of water, either for like lakes or creeks or ponds or whatever, and like effluent of like water processing facilities, sewage facilities, those kind of things. Also a little bit of oil analysis for like organic toxins in oils. I'm trying to remember what kind of oil specifically. I think a lot of it was transformer oil. For some reason, electrical transformers need oil. I don't exactly know why. Then soil quality. So this is like land, trying to figure out how much carbon content there is or other nutrients to consider its quality for maybe growing plants and things like that. But I ran a whole bunch of other tests, like, what else? Anions in water, fluoride, chloride, bromide, nitrate, sulfate, tannins and lignins in water, ultraviolet, UV vis, absorbance of water, those kind of things. So a lot of different experiences. I didn't really know the theory behind all the tests I was doing, but I got a lot of hands-on experience. I also have a master's degree in teaching English to speakers of other languages. So when I first came to Japan, where I'm living now, I started as an assistant language teacher, but there wasn't really room to grow in that field, so I decided to try to get a job at a university teaching English, and I was able to, but I had to promise them that I would get a master's in English. So I learned a lot, and I had a lot of fun studying that for like 2.5 years. It was all online, but ended with a dissertation. I wrote it. I got my MSc. Then I have a little bit of international baccalaureate training. I have IB Cat 1 or Category 1 training in physics and chemistry. So if there's any IB teachers watching this, you know that IB Cat 1 is not much, right? It's just introduction to IB and sort of the way the course is structured, IB chemistry or physics, with things like the papers, paper 1 and 2, the internal assessments, IAs, the collaborative science project, those kind of things. You get introduced to that. You might get a couple lesson ideas from other teachers in your group, but there's not a whole lot of what you would consider real training in these. So hopefully I'll get to do Category 2 sometime soon if my school helps me sign up for it. And then just my experience. So I have 4 years of experience as an IBDP chemistry/physics teacher. I've also recently been a CAS, or Creativity, Activity, and Service Supervisor, and an Extended Essay, EE Supervisor for chemistry and physics. The students I've been supervising haven't really got their results yet, so I can't say whether I'm doing a good job at that, but I'm at least learning how they work. And I've also been 2 years as a homeroom teacher. That's sort of not related to the whole chemistry and physics thing, but it means I've done like career counseling, mental health counseling, discussing with parents, so I know that side of being a teacher as well. So, I know some things, and I've worked really hard to try to learn the IB Science curriculum. So, let's move on. So we're going to go through the actual IB requirements and things that I recommend. So important documents for students. The 2025 Chemistry Guide. This document is really the end-all be-all for things that you need to know and how you'll be assessed in the class. Now, I don't think any of my students have actually read it from start to finish. I did read it from start to finish, at least the 2016 version, before I got hired, just to try to impress in my interview a little bit. But there's just a lot in there. There's a lot of like IB pedagogy, like methodology and teaching that students don't really need to know. So my students just usually trust that our textbook and my slides contain everything they need to know. But there is no official textbook for IB subjects like this. So if you really want to know what you actually need to know and what you'll be tested on, it's in the guide. And sciences were recently redone, so 2025 I think is the most recent one. I'll attach links for these things, if I can, in the video description. Next, the 2025 Chemistry Databook. This is absolutely key. This is the only bit of help that you will get on your final exams if you're taking IBDP chemistry. And it contains formula, constants, just various information that you will need but shouldn't be expected to memorize. So when students do homework, I say, the first time they do it, they can do it with textbook, with online resources and things. When they come back to review it, they need to be able to do the same questions just using the data book. There's often equations and things that you might expect to be in there that aren't. So you've got to be very familiar and knowledgeable about what's in the data book and how to use it. Textbook. So I generally use Oxford Diploma Program Chemistry Course Companion 2023 edition. It's the most recent Oxford chemistry book, I think. Now, this textbook is not perfect. There's quite a few mistakes in there, and there's not really nearly as much practice problems and questions as you would want. But the textbook is already huge. There's so much content in IBDP chemistry that I kind of forgive them for not having space to put that much more practice. There is a lot of filler sort of, connections to the real world that they try to make, nature of science, things in little boxes on the sides of the pages, which maybe isn't completely necessary for you to learn and write your exams, but it is nice from time to time. So I think this book generally has what you need to do well in the course, but you probably want to find some supplementary practice problems. Side note, this is not a document, but always have access to a scientific calculator. You can use an online one if you need, like from Google or whatever, some website, but it's nice to have one in your hands that you can use quickly. Smartphones generally do have calculator apps, and I think the one on my iPhone anyway, if you turn the phone horizontal, it will transform from a basic calculator into a scientific version, or there's probably some button you can press. But you need things like, control over your exponents. You need cosine and tangent and sine functions and their inverses, those kind of things, brackets, functions, to be able to do many of the problems. So I'd recommend you get one in your hands. I think you can get a cheap one for like 2,000 or 3,000 yen. I'm living in Japan, of course. I don't know, it's like 20 or 30 bucks. Canadian or American dollars. I am from Canada as well, so anyway, try to convert those into whatever makes sense to you. So I just want to go take a look at some of these documents, actually. So I'm going to close this slideshow for a moment. So the chemistry guide looks like this. Chemistry Guide, First Assessment 2025. Make sure you're not using 2016 or older than that, although it's mostly similar. The order of the content especially won't make a lot of sense. There's IB stuff, and you can look at what's in the table of contents here. Assessments, content, syllabus. These kind of things. Very important. But again, if you don't want to read the whole thing, I would forgive you. Data book, though, the next document I recommended, absolutely essential. You've got to have this, have a printed copy, use it to do your practice and homework. It's pretty nicely organized into different sections that you might need. In the textbook I use, Oxford Resources for IBDP Chemistry. Again, not a perfect book, but sufficient, I think. I'll be exploring other textbooks in the future, and I'll let you know if I find any better ones. Alright, let's go back. So from the subject guide, you can see the topics that will be in this course and sort of how many hours or teaching hours are expected to go into each. So the course is split into two halves, structure and reactivity. So structure is really just the way things are and exist, and reactivity is more about change and how to go between different structures. That's one way to think about it. So you can see the SL hours for each section there and the HL hours. And there's also practical work and collaborative science project and scientific investigation at the end there on the bottom right that are also required. So practical work is things like going to the lab and doing experiments, trying to graph your results. Collaborative science project I'll talk about in a moment. And scientific investigation is the IA, the internal assessment. So for SL assessment, you have an external assessment worth 80% of your scoring. So there is a paper 1 hour and 30 minutes. This is for a standard level. But it contains two sections, paper 1A, paper 1B. Paper 1A is multiple choice, so you would just fill in a bubble A, B, C, D and choose an answer. Paper 1B is data-based questions, so it kind of gives you results that a student or a scientist might have got in a laboratory, and you are expected to analyze it, maybe graph it, maybe work with experimental uncertainties to express a range of answers or measurements. So paper 1 is 36%. Then there's paper 2, which is the longer, usually more difficult one, which is short answers and extended response questions. 44% of your grade. And usually I try to focus on paper 2 because if you can do paper 2, you can probably do paper 1, especially multiple choice. Practicing for paper 1B is sort of its own deal. But if you have limited time, work on paper 2 type questions, and you'll probably be able to answer paper 1A questions anyway. Then there's the internal assessment. That's the remaining 20%. So that's your scientific investigation. This component is internally assessed by the teacher. So I internally assess my students' IAs at the school. I also supervise most of their data collection. But it is externally moderated. That means I give a write-up of what I think and a scoring of what I think based on a rubric or mark bands that the IB gives me. And then someone in the IB will check them and assess whether there needs to be modifications, either increase or decrease on the score that I gave. But so far I've been pretty good at hitting the right scores for my students. I don't really get changes in the moderation. Alright, so that's SL. HL is essentially just the same. You can look at this. I should also mention that this is the same for all the sciences, as far as I know, physics, chemistry, and biology. So HL is the same, but longer and more difficult. Paper 1, A and B together are 2 hours. And I should also mention for paper 1, A and B, you can choose how much time to spend on each of these. I think you get them both at the same time, and it's up to you what you're going to spend most of your time on. Paper 2 is extremely long, 2 hours and 30 minutes, and it is more difficult. It focuses on the HL topics much more. But the IA is essentially the same. Whether you're SL or HL, you've got to write an internal assessment on a topic of your choice, and you're expected to spend 10 hours of class time. Time you need beyond that needs to be done at home, and you will need time beyond that, I'm pretty sure. Alright, so this is from the subject guide. It's just sort of a outline or an idea of what we are doing here. So there's different skills that will apply to all the sciences. for chemistry as well: thinking skills, research skills, self-management skills, communication skills, social skills. So those surround the tools, which are experimental techniques, technology, using different instruments and machinery, and mathematics, manipulating numbers, and observing patterns. So these go into what we can kind of consider as the scientific method: exploring and designing, then taking that design or that experiment and collecting and processing data from some source, and then taking our analyzed data and making conclusions and evaluating the whole process of an experiment. And this is a cyclic matter that will continue over and over as we refine our hypotheses and theories and things like that. So this is just a really important way to think about science, and I think it's good to talk about this for a moment. So what exactly is the internal assessment? I'm not going to go too deeply into it here because it's a very specific IB thing. Maybe we can do a whole video on IA someday if people are interested, but it is an individual research project where you have your individual data and research question that you come up with. It kind of has to be okayed by your instructor. So they'll give you some direction in what is not clear or what's not possible. That's what I usually try to do. Now, recently in the new curriculum, it has been mentioned that some collaboration is allowed in experiments, but be very careful. I still generally tell my students, do it on your own. I think the collaboration that's allowed is just, you're allowed to help each other do some physical work when it comes to experiments, but your plan needs to be your own, your data needs to be your own, and your research question needs to be your own, and your written report needs to be your own. So you don't really want to steal anything or take anything from another student. You have to be very careful about this. If you want, you can go and read the guide yourself. Maybe I'll try to put a link in the description as well. So there's 3,000 words maximum on this, but this gets complicated as well. Like, there's a lot of things that don't count. So things that don't count are like headings, things that are in images, things that are in tables. It's really like the core paragraphs of your analysis that count to this 3,000 words max. So make sure you stay within that. My students almost always go over and need to figure out where to cut things, and it should usually be in the introduction, because over half of your IA marks come from the discussion, conclusion, evaluation. Anyway, your teacher is supposed to give you 10 hours of class time for this, but that can include the explanation, going to the lab, doing trials, and then doing your actual data collection. And beyond that, basically needs to be done on your own at home. So the assessment, as I mentioned, is shown here. It's 24 points you'll be graded on. 6 of that is research design, 6 points data analysis, 6 points conclusion, and 6 points evaluation. So some of these should be clear. It's just, students often ask me, what's the difference between conclusion and evaluation? Conclusion is looking at your data and trying to find patterns or useful points about it, or proportionalities. Whereas the evaluation is looking at your whole process from start to finish, when you started thinking about the experiments and research question, to collecting the data, to analyzing the data, and making conclusions about the data. What about that went well? What could you have done better? Those kind of things. It's really a holistic look at your whole IA process. So over half of your grade comes from conclusion and evaluation. It's super important. So that means even if you had a bad research question and poor data collection, if you can go and say, listen, I know now this didn't make sense, this was bad, this was a poor choice, this is what I would have done, You can still recoup a lot of points, I think, in the conclusion and evaluation section if you propose how to improve what you did. So before you do any IA stuff, I recommend you read the full assessment guide that's in the subject guide. I mentioned I don't expect all students to read the whole chemistry subject guide, but the IA section, I think you should completely read every word in that section. So practicals, these are things that your teacher and school will set up, and it really depends on what they can and want to do. But you got to spend a variety of hours, not just in the classroom doing math and looking at slides and pictures, but you've got to go get hands-on experience. So generally I try to set up 10 experiments for my students. So I have them here. Determine the formula of MgO, magnesium oxide, from the stoichiometric relationships part of the curriculum. Preparation of a standard solution, determination of molar mass of CO2, enthalpy change of neutralization for NaOH and HCl, that's from energetics and thermochemistry, determination of rate for hydrochloric acid and sodium thiosulfate reaction, that's chemical kinetics, acid-base titration using the standard solution prepared in experiment 2, also acids and bases, redox processes, construct a voltaic cell from zinc and copper half cells, so that's redox and electrochemistry, molecular shapes simulation and model building, this is mainly organic chemistry, and iodine clock reaction kinetics. Okay, we don't always get to all of these or do exactly what I said here year by year. It depends on what we have time for and what materials we have in my laboratory, as it will for whatever instructor and materials and lab that you have at your school. But those things are very good practice to help you get ready for preparing your own IA experiment. Next, there is a collaborative science project. This is kind of a, what would I say, offshoot. It is not academically marked per se. It's just something that you need to complete. So sometime during the 2 years, assuming you have 2 years, my school has 1.5 years, I know some schools have 3 years, but sometime during your IB-DP time, you must do a collaborative science project with members of all the science classes. So at my school, the biology, physics, and chemistry students all come together. We make randomized groups and they do some kind of project. You can also potentially do this between schools. We've invited different schools to our school and had their classes mixed with our students as well. Now, my school tends to do scientifically themed artwork exhibitions, especially recently. We used to just do like science experiments and projects and presentations, but with the new curriculum, IB has recommended us some new ideas and push the boundaries of what's possible. So we do artwork recently. So that can include, painting, drawing, models. It also includes dramatic arts, videos, song, dance, those kind of things we've had. But you must then write a short reflection about the process that you did and the results, and sort of what you learned, what you accomplished. But it's just like a one-page reflection, you get it done. My school usually does it in the middle of first year during our summer holidays in Japan. So what's the planned schedule for my classes? Generally, we follow the order of the IB syllabus, which is the same as the order of the Oxford IB chemistry textbook. But there is also the tools section. It's difficult to decide when to do this content, but I'm actually going to do quite a bit of it at the beginning of the class, and then sort of as it is necessary, as it links to actual topics in the syllabus. I think a lot of people forget about the tools section of the syllabus, but content from there can absolutely appear on exams, especially paper 1B. So you got to study it explicitly, just like anything else. Alright, this video is getting to already 30 minutes, so we'll stop soon. I just want to cover one more thing, which is IB command terms. So this is something that's also very specific to the IB diploma program, but it's words that will often appear in your practice questions and exam questions. In fact, in paper 2, I think every question or request of you has one of these command terms in it. So I usually give my students a paper or have them look at the slide and try to really understand what these command terms are in the IB definition. So if you guys want, you can pause the video and look at this, but these should be also in the IB chemistry subject guide. I think the slide here I use is maybe a little bit older than the 2025 guide, so there might be a couple extra in here, but I mean, it's good to know those as well. So this is the first page. I have another page as well. So these are the next set of command terms. So I really recommend you get used to doing exactly the definition of what these command terms say when they appear in a certain question, right? You want to know the difference between sketch and draw, right? You don't want to not include something that's required in a drawing. You don't want to waste time adding too much into a sketch. Difference between explain, describe, outline, these things are really important to get the marks and not waste time doing things you don't need to do. So I usually do some kind of like fill in the blanks or matching activity after my students have studied this for a while. I'd recommend you do the same. Alright. So, yeah, I think we'll stop this video here. So this video contains just things about my background and the IB science, specifically chemistry. So I'm sorry if this didn't particularly help people who aren't doing the IBDP program, but I promise my upcoming videos will do so. So that's all for today. Thank you for listening, and I'll catch you guys next time.